Speech synthesis, also known as text-to-speech or TTS, is the process of generating human-like speech from text using artificial intelligence algorithms. This is a field that is quickly evolving. Early TTS systems sounded very unnatural, while the modern ones work well to the degree that they are being widely used in applications such as assistive technologies, education, public announcement systems, and in-car navigation. Turn left in 200 meters. In fact, the technology has matured to the level that we will use a commercial TTS system to provide the voice for the rest of the video.
This is how a typical pipeline of auth system looks. Different approaches are used to generate the speech representation, such as spectrogram. The final component is called a vocoder. It converts intermediate speech representations into audible audio waveforms. We will also hear some examples of different approaches that were done for Slovenian language. Many thanks to Tomasz Szef for providing the audio clips. The sample sentence says, "In warm nights, I am lying in bed and looking through the open window." Concatenative synthesis was a popular approach in early systems. It involved splicing and concatenating, putting pieces together in a chain, small segments of recorded speech to generate the desired output. While these systems could produce intelligible speech, the resulting audio often sounded unnatural due to the lack of prosody and pitch variation, and could contain audible glitches. Let's hear it.
U toplých nočích ležím v posteli, hledám skozi otevřené okno.
We can further improve this with some machine learning to account for correct intonation.
U toplých nočích ležím na posteli, hledám skozi otevřené okno.
Parametric synthesis models the human voice by generating speech from a set of acoustic parameters. Hidden Markov models were widely used for this purpose, capturing the statistical properties of the speech. Although based synthesis improved upon concatenative systems, it still suffered from issues such as muffled speech and limited expressiveness.
V toplih nočeh ležim na posteli in gledam skozi odprto okno.
This also works for other voices.
V toplih nočeh ležim na posteli in gledam skozi odprto okno.
Here, these models were trained on around 50 hours of speech recordings read by professional speakers. The introduction of deep learning has led to a significant leap in speech synthesis quality. The groundbreaking technology was WaveNet 4, introduced in 2016. It uses deep learning techniques to generate highly natural-sounding speech. It is based on a deep convolutional neural network architecture and models the raw audio waveform directly, instead of relying on intermediate representations or handcrafted features. Another approach, Tachotron, was introduced in 2017 by Google. Tachotron end approach is based on sequence-to-sequence models. It simplifies the speech synthesis pipeline and achieves high-quality synthesized speech with accurate prosody, stress, and intonation. It also reduces the need for complex feature engineering and intermediate representations, as it learns to map text inputs directly to spectrogram outputs. What you are hearing now is using the modern approaches that we have been just discussing. Even if it already sounds rather good, what do you think? There are still several challenges to be addressed. Some of them include naturalness, which refers to reproducing prosody, stress, intonation, emotion, and expressiveness with varying speaking styles and emotions. Think of sarcasm or humor, code switching and multilingual synthesis, handling out of vocabulary works, robustness, adaptability, low latency for real-time synthesis, ethical issues, more on those in the deepfake video, and accessibility and inclusiveness. At the end of the unit, You will find several questions to test your knowledge. Here is one of the questions. In the context of X, what does a vocoder do? A extracts linguistic features from text. B generates speech from acoustic parameters. C converts spectrograms to audio waveforms. D translates text into phonetic representations.